Good day, everybody. Uh, Today we are going to talk about menstruation, normal and menstrual disorders or disturbances. That will be in two parts. We'll start by part one, which shows the contents of the talk will be puberty, then ovarian follicular development, then hypothalamic pituitary ovarian axis and its role. Then they go into the menstrual cycle with its ovarian phases and uterine changes. The ovarian phases are follicular and luteal phases, while the uterine changes are proliferative and secretory. Then we go into menarche and failure of ovulation or disturbances that could occur from failure of ovulation. So what's puberty? Simple definition for puberty is that it describes the series of events in which a child matures into a young adult. That's in general. Of course, here we are dealing with female puberty. Certain changes resulting from certain events changing the child into a mature adult. It encompasses a series of endocrine physiological changes which result in the ability to ovulate and menstruate. That's in the girl. These changes include the development of secondary sexual or sex characteristics, the growth spurt that occurs for the child, and achievement of fertility. We talk about adrenarche, which occurs with the regeneration of the zona reticularis in the adrenal cortex or the zona reticularis of the adrenal cortex, and then production of androgens, and ultimately stimulate the appearance of the pubic hair. That's adrenarche. So there is another term we use, gonad arc. This describes the activation of the hypothalamic pituitary ovarian axis or hypothalamic pituitary gonadal axis. Involves pulsatile release of GnRH, gonadotrophin releasing hormone secretion from the hypothalamus in a pulsatile fashion. It stimulates the anterior pituitary to produce LH and FSH. These, in turn, trigger the ovary to produce estrogen. So to look at it, the changes occur at the hypothalamus, producing GnRH in a pulsatile fashion, acting on the pituitary to produce FSH and LH in a pulsatile fashion too, and these act on the ovary to produce estrogens. The sequence usually includes accelerated growth spurt. Initially, the child will have growth, followed by the development of the breast, tail arc, then development of the pubic and axillary hair, pube arc, and the onset of menstruation, menarche. Usually, these go in this same order and sequence. Breast initially, pubic and axillary hair, followed by menstruation in a young girl. This is the usual way. Sometimes, so the length time from the breast development or breast bud development to menstruation, typically 2.5 years. Adrenarche, as we have said, occurs in the development of the adrenal cortex, zona reticularis. The age is between 6 and 8 years. The adrenal gland begins regeneration of the zona reticularis. The inner layer of the adrenal cortex is responsible for the secretion of sex steroid hormones. As a result of this regeneration, the adrenal gland produces increased quantities of androgens. That's from the inner layer of the adrenal cortex. These androgens are dihydroepiandrosterone sulfate, dihydroepiandrosterone, and androstenedione. So these are hormones initially produced from the adrenal cortex. Production of these androgenic steroid hormone increases from the age 6 to 8 years when it starts to reach its maximum at the age of 13 to 15 years, differing from one child to the other. The primary stimulus of adrenal arc is unknown. So we go to the gonadal arc or gonad arc. Begins by the age of 8 years. The pulsatile gonadotrophin releasing hormone secretion is increased from the hypothalamus. There is also a change of sensitivity of the neuroendocrine system to negative feedback by the gonadal hormones. It's important, the negative feedback, which we'll come and see in a minute. This leads to subsequent pulsatile secretion of LH and FSH from the anterior pituitary. So initially, increase in the pulsatile production of GnRH, leading to more production of FSH and LH from the anterior pituitary is still in a pulsatile fashion. This increase occurs mostly during sleep initially, and they fail to lead to phenotypic changes. So the importance of this pulsatile release at the pituitary and the hypothalamus initially occurs only during sleep. But as it goes on, the pulsatility comes to be throughout the day, eventually leading to the stimulation of the ovary and subsequent production of estrogen. As the girl grows, pulsatility changes, becomes all through the day, acting on the ovary, producing estrogen. This triggers the characteristic breast bud development associated with puberty. So estrogen is the responsible for the development of the breast buds. The positive feedback of estradiol also results in the initiation of the LH surge and the ability to ovulate. And as we will see, we got a negative and positive feedback of either of both estrogen and progesterone. So the positive feedback here of estradiol results in the initiation of the LH surge and puberty. The first stage of thelarch, which is the development of breast buds, usually occurs around the age of 10 years. Thelarch is usually the first phenotypic sign of puberty and occurs in response to the increase in circulating estrogen. So the first phenotypic change you note in the girl as a sign of puberty is the development of the breast buds as a result of estrogen production. Concomitantly, this leads to estrogenization of the vaginal mucosa and growth of the vagina and uterus. So estrogen also acts on the genital tract of the girl. Further development of the breast will continue throughout puberty and adolescence. So it started about the age of 10. A response to estrogen continues to develop all through adolescence. The pubic hair usually occurs around the age of 11. So First thing is the breast blood, then the pubic hair, and often accompanied by the growth of axillary hair. Pubarch usually follows tail arc, in normal variant may occur with pubarch preceding or coming before tail arc, particularly in African American girls. The normal or the common thing is the tail arc first, followed by pubarch. In some African American girls, that could be the reverse, tail arc occurring first. The growth of the pubic hair and axillary hair is secondarily to the increase in circulating estrogen. So you will see now estrogen acts on most of the female genital organs to let the girl go into puberty. So having said this about the hypothalamic pituitary axis and development of stages of puberty and signs of puberty, we come to the normal menstrual cycle. It involves organs, which are the hypothalamus, the pituitary or anterior pituitary gland, the ovary, and the uterus. All are involved to each one of them have a certain role to do, and eventually the ultimate result is menstruation. The normal menstrual cycle could be divided into two 14-day segments based on organ under examination. We generally say the normal menstrual cycle, if we take it, usually it's between 21 and 35 days, but commonly it is 28 days. So we divide it into two periods, each of 14 days, and we look into that on the organs concerned. The first organ is the ovarian cycle, what happens in the ovary, and then the uterine cycle or changes, what happens as a result of the hormones produced by the ovary. The ovarian cycle itself could be divided into two, the follicular phase and luteal phase. And in each one of them, the hormonal milieu present is different. Then we go to the uterine cycle. We usually divide it into proliferative and secretory phase. So talking about the ovary, in the menstrual cycle, we talk about the follicular and luteal phase. When we come to menstruate or to the uterus, then it is the proliferative and secretory phase. As I have just mentioned, a normal menstrual cycle lasts for about 21 to 35 days. So any range within this is normal. Women or girls may worry about it's coming irregularly, but if it's coming between 21 and 35 days, that's normal. Usually 2 to 6 bleeding days, and the flow usually is about 20 to 60 ml. The flow of blood that comes out. Duration of the bleeding, amount of the bleeding. So what happens oogenesis? Egg formation usually takes place in the ovaries, and it starts usually in utero. After delivery, there is no more egg formation. It starts, the initial steps in egg production occur prior to birth, where diploid stem cells called oogonia divide by mitosis to produce more oogonia and primary oocyte. And you can see here, this is the oogonium, the singular, by mitosis, producing additional oogonia, and then producing the primary oocyte. So the primary oocyte each has begun the first step of the first meiotic division, stopping at the diplotein stage of meiosis. So mitosis, dividing here, giving more oogonia, primary oocyte, then that will develop into the secondary oocyte, and after that, after stimulation, then it ends with an ovum or an egg called here. This is the one that is ovulated, and is the one that hopefully will be fertilized for pregnancy to occur. So this in utero, it stays at the first meiotic division, stopping at the diploid stage of meiosis. No further development occurs until later when the girl becomes sexually active. So the primary oocyte grows much larger and completes meiosis one, forming a large secondary oocyte and a small polar body that receives little more than one set of chromosomes, one set of chromosomes. So as I have shown in the previous slide, divides to form the secondary oocyte and the polar body. In humans and most vertebrates, the first polar body does not grow on to meiosis 2. Secondary oocyte does proceed as far as metaphase of meiosis 2 and then stops. Only if fertilization occurs, meiosis 2 will be completed. Entry of the sperm into the ovum restart the cell cycle, which has been stopped at meiosis 2. The follicular development, you can see in this graph, the number of oocytes peaks in the fetus at 6 to 7 millions by 20 weeks gestation. So the number is highest at 20 weeks gestation. This 20 weeks gestation, and you can see here the height of the oocyte peaking up to 6 to 7 millions. Then atresia of this oocyte or oogonia occurs rapidly by follicular atresia. At birth, there will be only about 1 to 2 millions. This is at birth. This is birth here. At birth, it will be about 1 to 2 millions. Then, when she reaches puberty, due to atresia, most of those 1 to 2 million oocytes will be will have atresia. They won't be there. Only about 300,000 are available for ovulation. That is after puberty. And out of these 300,000, only about 400 to 500 will ultimately be released during ovulation. So the one that be released is very low. Instead of all those 6 to 7 millions, only about 400 to 500 will ultimately be released and will be ready for fertilization, for ovulation initially, then for fertilization. By the time of the menopause, the ovary will be composed primarily of dense stromal tissue with only rare interspersed oocytes remaining. So oocytes enter the diploid resting stage of meiosis in the fetus. Persist is this stage till ovulation starts. At the diploid stage, single layer of 8 to 10 granulosa cells surround the oogonia to form the primordial follicle. The primordial follicle formed by the oocyte in the diploid stage, surrounded by 8 to 10 granulosa cells. The oogonia that fail to become properly surrounded by granulosa cells undergo atresia. So this is when we look at the about 400 which will remaining there. Thus, most oocytes are lost during fetal development, and the remaining follicles are steadily used up through the intervening years until menopause. The remaining will be used up within each menstrual cycle. Some of them will be used up till the menopause, whereby they will stop completely. They won't be there. This theory of all the oocyte being present at birth, none will be formed after birth, is challenged now by some research is done on the mouse or rats. It shows that production of oocyte could occur after being born. This has not been proven in human beings, that we are dealing now with researches in stem cell, and still we believe on the theory that the girl will be born by all her possible oocytes will be used gradually within each menstrual cycle till the age of the menopause, where all will be used or gone. So we go into hypothalamic pituitary ovarian axis. Process modulated by ovarian sex steroid hormones, which are progesterone and estrogen. Low level of estrogen have an inhibitory effect on LH production, ودي negative feedback. That is at the beginning of the cycle, there is low level of estrogen. Thus, LH will not be produced. As FSH continues acting in the follicular phase, more estrogen will be produced. And then we will say high level of estrogen will increase the LH production, ودي positive feedback. So estrogen and the negative feedback and positive feedback. The high levels of circulating estrogen in the late follicular phase of the cycle act by the positive feedback mechanism on the hypothalamic pituitary ovarian axis to generate a periovulatory LH surge from the pituitary gland. At the end of the follicular phase, the estrogen level will be high, acting on the pituitary, leading to production of LH surge that will stimulate the growing of follicle to ovulate. And you will see here how the process acts. Here is the hypothalamus by the gonadotrophin releasing hormone acting on the pituitary. In a pulsatile fashion, the pituitary will produce FSH initially and then a surge of LH due to the ovarian steroids in the ovary. And what these steroids produce, they act on the uterus, the estrogen and the progesterone. So this is how it acts, how the cycle is usually generated through the hormonal milieu. So we say the hypothalamus secretes GnRH in a pulsatile fashion, which controls the pituitary hormone secretion, stimulating the basophil stills of the pituitary to synthesize the release of gonadotrophic hormone, FSH, and LH in a pulsatile fashion too. Pulsatile means the level of production is not the same all the time. It is at one time low, then a peak occurs, then it comes down and goes that way, up and down, in a pulsatile fashion. FSH and LH pulsatility lasts throughout the day, leading to stimulation of the ovary to produce estrogen and progesterone. That is estrogen. What happens for the progesterone? Progesterone have a positive feedback effect on the pituitary LH and FSH secretion and contribute to LH and FSH surge. High level of progesterone in the luteal phase inhibit the pituitary LH and FSH production. So initially leads to an increase in LH. When it becomes high level, it inhibits the pituitary producing more FSH and LH. The positive feedback effects of low progesterone levels occurs via increasing the sensitivity to GnRH in the posterior pituitary. Sorry, in the anterior pituitary. That is the positive feedback. The negative feedback, on the other hand, its effects are generated through both decreasing the GnRH production from the hypothalamus and decreasing the sensitivity to GnRH in the pituitary gland. So you can see the positive feedback, increasing the sensitivity to GnRH in the pituitary gland. The negative feedback acts both at the level of the hypothalamus and at the level of the pituitary gland, leading to decreasing production of GnRH and decreasing the sensitivity to GnRH on the anterior pituitary. And this is a picture which you will see in your book showing the hormones initially starting. This is the hormones here. This is the FSH being produced, leading to more production of E2 or estrogen. Then that will lead to surge in LH, leading to ovulation. Ovulation here, and you can see here, this is the ovum being released. Then further hormones will continue, more progesterone will be produced, E2 will be produced, but to a lesser degree, while both LH and FH will come down. And that we'll see with the growth on the ovary here. These are the changes of the hormones effect on the ovary. In this level, taking the primordial follicle, a lot will start. There will be a dominant one. It grows till it ovulates. Then after that, the corpus luteum will be formed. The effect will be seen on the uterus here. You will see how the uterus changes from a very low level of tissues occurring in it, which we will see mainly vessels and connective tissue, to a very densely one that will lead eventually to menstruation. So the normal cycle, just to recapitulate on what we have said, the normal menstrual cycle, all the time think about it at two levels: the level of the ovary and the level of the uterus, endometrium. Obviously, these are controlled by higher level, the pituitary and the hypothalamus. So what happens at the ovary? The ovary during the menstrual cycle will go through three phases. اللي هي بنسميها follicular phase, ovulatory phase, and luteal phase. While the uterus or the endometrium in the uterus go through two phases: the proliferative phase and the secretory phase. So let us take them one by one. What happens in the ovarian follicular phase, the initial? The withdrawal of estrogen and progesterone during the luteal phase of the prior cycle causes a gradual increase in FSH. A cycle previously had a high level of estrogen and progesterone. Once she menstruates and bleeds, these levels will come down. When they come down, they stimulate the production of FSH from the anterior pituitary, leading to a gradual increase of it. This FSH acts on the ovary again. When it acts initially, there is approximately 5 to 15 primordial follicles will start to grow, initiating the follicular phase in the ovary. What happens then? Of these primordial follicles, the 15 of them, only one becomes the dominant follicles and develop and matures until ovulation. The rest will become atretic, only one, but a rare situation where the twins non-identical twins, two follicles could develop. So only one will be the dominant follicle, and this dominant follicle is destined to ovulate, produces estrogen that enhances the follicular maturation and increases the production of both FLH, FSH, and LH receptors, increases the production of the receptors. So they talk about the two-cell theory. Sometimes they call it the two-cell theory or the two-cell two-gonadotrophin hormone theory. What is in that? It means that the LH stimulates production of androgens, androstenedione, from the cholesterol and pregnenolone in the theca cells. So LH leads to production of these androgens. These androgens produced from the theca cell are then transported into the granulosa cell, where FSH stimulates the conversion of androgens to estrogen. So you can see initially androgens produced from either pregnenolone or cholesterol, produced by the theca cell, moves from the theca cell of the ovary to the granulosa cell of it, where they, through the action of FSH, these androgens are converted to estrogens. So rising estrogen levels have negative feedback on the pituitary FSH secretion, while the dominant follicle is protected from the decrease in FSH by its increased number of FSH receptors. Why the dominant follicle does not go atresia like the others is being protected by the increased number of FSH receptors, though the FSH may be low, but the receptors are more. So this will lead to ovulation. Ovulation initially is the start of menarche, the initial of the first one. Menarche means the first cycle. The primordial follicles containing the oocyte are rested, as we have mentioned earlier on, in the first prophase step in the meiotic division, will start to activate and grow in a circular fashion. So at the end of the follicular phase, estrogen levels eventually surge to reach a critical level that triggers the anterior pituitary to release LH surge. So the follicular phase, controlled by FSH, produces estrogen from the dominant follicle. The estrogen reaches a certain level, will act through the negative feedback, and they stimulate the production of LH surge. The LH surge triggers a resumption of meiosis of the oocyte and induces production of progesterone and prostaglandins within the follicle. Okay, what happened then? The progesterone and prostaglandins in turn are responsible for the rupture of the follicular wall, releasing the mature ovum or ovulation. This is the ovum here, oocyte is developing, and then eventually, as the result of progesterone and prostaglandins, this will rupture. It will be picked up by the fimbrial end of the fallopian tube, and it goes through the fallopian tube by the cilia of the fallopian tube. It moves the ovum down, and the sperm will meet in the middle in the fallopian tube, and fertilization takes place. The ovum usually passes into the adjoining fallopian tube and is swept down to the uterus by the ciliary lining of the tube. This process takes 3 to 4 days. Fertilization of the ovum occurs within the fallopian tube, and it must occur within 24 hours of ovulation, or otherwise the ovum will degenerate. And as we have mentioned earlier on, the life span of an ovum is just 24 hours. So the process it takes to come down till the level, till the uterine cavity, if it is not fertilized, it will be about 3 to 4 days. While on the other hand, if it's being fertilized, that takes place in the fallopian tube and it's usually within 24 hours of ovulation. So after that follicular phase, ovulation, we go into the luteal phase. What happens in the luteal phase of the ovary? The luteal phase begins after ovulation. The granulosa and theca interna cells lining the wall of the follicle form the corpus luteum, and there is stimulation by LH. So immediately the ovum released, the remaining part of it will form the corpus luteum. This corpus luteum continues to synthesize estrogen and significant quantities of progesterone. It is important to stay there for if fertilization has taken place, it will keep producing the estrogen and progesterone till the placenta takes over. So the cause of this caused the endometrium to become more glandular and secretory in preparation for implantation of fertilized ovum. If fertilization occurs, the developing trophoblast synthesizes HCG, human chorionic gonadotrophin. In the luteal phase again, the human chorionic gonadotrophin maintains the corpus luteum so that it can continue production of estrogen and progesterone to support the endometrium. So you will see fertilization, then HCG is being formed and released, acts on the corpus luteum to produce more estrogen and progesterone, and their job is to lead to support of the endometrium for the fertilized ovum and implantation. This continues until the placenta develops its own synthetic function within about 8 to 10 weeks of gestation. So if you see on ultrasound a cyst in early pregnancy, beware that cyst could be the corpus luteum, which has an important function during the first 8 to 10 weeks. If fertilization with its concomitant rise in HCG does not occur, the corpus luteum degenerates. Then progesterone levels will fall, the endometrium is not maintained, and shed causing menstruation. So at the ovary now, we talked about the follicular phase, what happens into it, followed by ovulation, and what happens in the luteal phase. So this is we stop here as part one of the discussion or the